Now if for example x is given to be -7 to 6 and x belongs to z. We know that z is a set of integers. Then find number of solutions. Find number of solutions of this inequality. Number of solutions means number of integral solutions satisfying -7 to 6. Okay, so think about this. So the hint would be draw the number line and count, or else directly you can count if you can. Okay, it won't be that tough. Okay, so that is the hint. Use number line or use calculate it mentally. Okay, now we will move on to the solution. So before moving on to the solution, so many of you might have done this. So number of solution is x equals to -6 to -1, 6, 7 and 5, 12 solutions. The answer is 12 solutions. Now the solution is this: x greater than -7, so x is -6, -5, -2, -1, 0, 1, 2, 3, 4, 5. So 5, 6, 7, 8, 9, 10, 11, 12. 12 solutions. Okay. Let's move on to the next example now, guys. If suppose in the same question, let's take this as a part B, if it is -7 less than equal to 5 by 3 and x belongs to z, then the question is same. Find number of solutions when x is -7 to 5 by 3. So again the same way we will do, that would be the hint. So the solution would be, the answer to this question would be, this is, since it is 5 by 3, it is 1.67, so it would be 8. Why? Because x equals to -6 will satisfy, -5 till -1, 0 and 1. Equal to 5 by 3 won't matter, because x, since it's an integer, we cannot take x equals more than 1, although 1.67 is included, but it won't make sense here. So if you count it, it is 8 solutions. Okay, so that we will do. Now in the same question, let's say if x is from -7 to 5 by 3, same, and x is z. Now if I ask you, find x having highest absolute value, highest absolute or highest magnitude, or highest magnitude. So how do we define it, guys? So the hint would be magnitude. Highest magnitude means x should be integer, and x, the modulus of x, this should be max. The modulus means, what is modulus? Like for example, -10, modulus is +10. If it is positive number like 11 by 3, it would be 11 by 3. Modulus of 7 is 7. modulus of pi is plus pi, it is positive only. So it, for example, minus 11 is plus 11, so it converts negative to positive, and it, the positive, in case when it is positive, it will give the same answer. This, these two vertical bars, if a number is placed inside it, it gives a positive number in return, and this is what we call modulus of x, or this two vertical bar is known as modulus operator. So that way we have to find, guys. So the solution would be uh, starting first we will take the intersection of this and this. So as usual, x starts from minus 6, minus 5 till minus 1, 0 and 1. Now if you take moduluses of all those numbers, minus 6, minus 5, 0 modulus is 0, 1 modulus, so modulus of 6 is 5, and so on. So the maximum is, as you can see, find x having highest absolute value. So if this is maximum, in that case x is minus 6, because minus 6 mod came out to be 6, which is maximum of all the numbers given in the question. Okay, so this is the highest absolute value, or the magnitude wise it is the highest value. Okay, so we can say that in order to find the magnitude wise highest value, we have to discard the negative sign. Okay, that way also we can think. Now moving on to our next subtopic, guys, which is, now we will see, in order to solve linear inequalities, quadratic inequalities and other inequalities, we need to have some rules of inequalities. For example, if I write one question, this equals to 7, in the next step you will take minus 1 here, this becomes 8. So now you can see that this is what I have done in equality. It was transposition. This is what you have learned in the previous classes, and now in the next step I took this 2 in the denominator. So this is what I called, from here to here, this is what I call transposition, and from here to here I called cross multiplication. This is what you have done, you have seen, you have learnt in case of equality equations. Now the question arises, if suppose the question, instead of equal to 7, if it is less than 7, greater than 7 and so on, does the same rules applies to inequality questions as well? So yes, more or less in many cases uh, it applies the same, with some exceptions. There are some exceptions also, that we will see. So we will study the rules related to inequality now. Rules of inequalities. There are several rules, but we will see them, we will study them one by one with some illustrations, so that you can absorb each of them effectively. So rules related to inequalities, TIs. So the first rule that we will see would be, if A is greater than B, then if I add a number both sides, same number, the sign of the inequality would be the same. C is any real number. Any real number, any constant, we can write it C belongs to set of R. This is what we call set of real numbers. Set of real numbers means real numbers includes all set rational numbers, irrational numbers, all integers, natural numbers. Real numbers is a superset of all these things, these infinite sets you might have seen in the chapter sets. Okay, so C belongs to R means C can be a real positive number or it can be negative number. Sometimes it is, if I write like this, C belongs to R plus, this means set of positive numbers. Positive numbers. Similarly, if I write C belongs to R minus, it means set of negative numbers. Okay. Now here A greater than B, if I add by a constant plus C, if I add by a constant, then the sign of inequality remains unchanged. Okay, C can be any number. The proof lies in number line. Like if suppose since A is greater than B, then A would be on the right side with respect to B on the number line. Now if you add B and A by a constant number C, it will get shifted equally by a distance C. So this becomes B plus C, and similarly in the same way it gets shifted, A gets shifted to A plus C. So again, as you can see, A plus C is lying on the right hand side with respect to B plus C. So therefore A plus C, since if A is greater than B, the same sign would be there for A plus C and B plus C also. A plus C will also be greater than B plus C. So in the similar way, if here equality is there, can you place equality here as well? So yes, here also we can place equality here. So for example, if 7 is greater than equal to 2, if I add here in this proof, I have taken C to be positive. That's why B plus C was on the right hand side of B. In the similar way, it can be proved for C negative. That's why I said that it is valid for all C, whether it is positive or negative, it is valid for every C. This inequality rule number 1. So 7 is greater than 2. If I add by plus 3, so as you can see, it holds. 10 is, this is true. 10 is greater than equal to 5 is also true. So for negative also, for example, if 11 is greater than 7 by 3, if I subtract minus 1 by 3 both sides, okay, from here to here, I added a constant C which is negative in this case, as you can see here. So uh, this is 33 minus 1 by 3, 7 minus 1 by 3, this becomes 32 by 3, okay, and this becomes 6 by 3, which is 2, and 3 10.67. So this is true. So we can say that in a similar way, if A is greater than B, we have seen. Similarly, if A is lesser than B, and if we add C both sides, what about this here? What will come? So yes, here also the sign would be same. Had it been equal to A less than equal to B, A plus C adding by a constant plus adding by plus C, which is where C is any real number, the inequality sign would be the same, or it won't be changed, or it will remain unchanged, guys. Okay, so if suppose A plus C lesser than D is given, now what I did, I added minus C both sides, so the sign would be the same. here it was less than, here again it would be less than. So this cancels out, a lesser than d minus c. So by looking at this from first step to the second step, it seems that the law of transposition holds here in case of inequality. Like if you take c on the right hand side, it becomes minus c. It is the same as what you have learned in equality. The example, if you can see here, if you take minus 1 on the right hand side, minus 1 becomes plus 1. Had it been plus 1, it would have become minus 1. So that this is the transposition which holds for equality, also holds for inequality, guys. So from first step to third step, it came, the intermediate step you can skip. This step won't be required. For example, if I say x minus 8 less than 5, in the next step directly you can write 5 plus 8 or minus 8 will come. So yes, plus 8 it will come. So the middle step was what? Which you can skip. We added 8 both sides. X minus 8 plus 8 less than 5 plus 8. This cancels out with this and you will get the next step. So this step you can skip. But this is the fundamental step. Okay. So x less than 13. Now in inequality based questions we have to write the answer in interval form. So x less than 13, as you can see here, less than 13 means towards left from minus infinity. So we will write answer as x belongs to, yes, minus infinity to plus 13. That way we will write. Okay. Now in the similar way, let's take another example. 7 greater than equal to x minus x plus 4. So again using transposing it, plus 4 becomes, yes, minus 4. So this becomes x. So 3 greater than equal to x. Yes, can we write it like this, x greater than equal to 3? So in the previous lectures we know that this is also correct, this is also correct, but this is mainly used. So x greater than equal to 3, 3 we will plot, or directly also you can write if you have practiced enough. X belongs to, the final answer would be 3 to infinity. Sometimes the answer is x greater than equal to 3, this itself is the answer. So, but in most of the cases this is the regular format of writing the answer in interval form, as I said. So that way we can write. Another example, let's take minus x plus 1 greater than equal to uh, 12. So what I will do, I will take minus x on the right hand side. Okay. So the solution is straightforward. Minus x, if it will, is transports on the right hand side, it becomes plus x. Now if I transpose 12 on the left hand side, it becomes minus 12. So x minus 11 greater than equal to minus x, equivalently we can write it as, yes, x less than equal to minus 11. So the what the answer is, so lesser than minus 11, guys. What happened? So guys, so the answer would be x less than equal to minus 11, there seems to be some, yes, so this is minus 11, okay, so x less than minus 11, it is minus 11 lesser than, minus infinity to minus 11 included, x belongs to minus infinity to minus 11, guys. So that way we will do. So this is what we call the rule of transposition, okay. Now let's move on to the next uh, example, the next rule rather, okay, which is if a is greater than b and if I multiply it by a constant. Now this time uh, please note that this constant is a positive constant. So if I multiply by plus c, where c is positive, or we can write it c belongs to which set? Yes, r plus. So what about the sign here, guys? The sign here would be a greater than only. So in the similar way, it can be established by that by multiplying by constant c, you can take c greater than 1, you can take c between 0 to 1, okay, and using number line in the similar way you can prove the way I proved when I added plus c both sides. This can also be established. A greater than b, ac greater than bc. If a is greater than equal to b, ac is greater than equal to bc. Equivalently, if I write a less than b and if I multiply both sides by a positive constant plus c, so again the sign of inequality will remain unchanged. And if it is a less than equal to b, here also it would be a less than equal, ac less than equal to bc. Multiplying by positive constant to both sides of an inequality won't change the sign of the inequality. This is the rule. Okay. So let's take some examples on this. Uh, 11 greater than 6 multiply by half both sides, guys. This becomes 11 by 2, this becomes 6 by 2, so which is 11 by 2 is 5.5, greater than 3, which is true. This was also true, okay. So that way we can do. Now another example. So let's take some example. 3x greater than 11, okay, we have to find x. So what, in order to find x we have to remove 3. So in order to remove 3 we have to multiply both sides by what? Yes, 1 by 3. So 3x into 1 by 3 greater than 11 by 3. So 3 gets cancelled. We will left with 11x greater than 11 by 3, which you can write in number line 11 by 3. On the right hand side it will go 11 by 3 to infinity is the answer. Okay, guys. So let's take another example now. 5x less than minus 4. Find x. So what is the answer to this, guys? Okay. So what we will multiply? So hint is as usual, multiplying both sides by 1 by 5, because we have to remove x 5, the coefficient. So 5x gets multiplied 1 by 5 minus 4 by 5. This cancels out. We are left with x only. X less than minus 4 by 5. So had it been less than equal to, the sign would have been would be continued as less than equal to only. So minus 11 by minus 4 by 5 lesser than, so it would be minus infinity to minus 4 by 5. Now minus 4 by 5 is included, so x belongs to minus infinity to minus 4 by 5 is the answer, guys. Okay, so as you can see here, uh, in this example, if you notice, from first step to from this step to this step, if you notice, guys, uh, we have shifted this 5, which was a coefficient of x, to this side on the right hand side like this. So this is kind of cross multiplication of positive numbers. Okay, so we can say that cross multiplication multiplication is allowed. Cross multiplication of coefficient of x can be done. It is allowed. Is allowed, or we can do it. Cross multiplication of, so from first to third step is you can see, it seems that 5 came from LHS, from in the as a coefficient in the numerator, it came in the denominator. So in the similar fashion, if I write another example like 18 greater than equal to 7x, can I write it like this using this law? Is it right? I have shifted this positive 7 cross multiplied, which was a coefficient of x, and it came to the denominator. Hmm? So yes, we can. This is correct. Okay. So what about, you might be wondering, what about the negative? If the coefficient is negative, what we can do? Like that also we will see, guys. For example, let's see another example. 3x by 5 less than equal to 2 by 7. Find x. You just try this. Okay. So the hint would be what? Yes, hint would be basically the cross multiplication of what? This 5, it is in the denominator. Since it is positive number, it can be cross multiplied here. This 3 can be cross multiplied here. Okay. Cross multiplication of positive numbers, as I said, is allowed. So in the next step, this becomes x less than equal to 2 by 7 into 5 by 3. That's how we do. That's the solution. So x less than equal to 2 5s are 10, 7 3s are 21. We can write like this. Or if you want to do it by the property, we have to multiply this by what? To remove the coefficient 3 by 5, we have to multiply it both sides by 5 by 3. So again, if you multiply by 5 by 3, 2 by 7 into 5 by 3, this 3 3 and 5 5 gets cancelled. Now again you will get the same result. Okay, so the multiplication of cross multiplication of the coefficients is allowed, guys. It is actually the same as if you are using this rule of multiplying by a positive constant both sides. Any way you can do, whichever you feel like is comfortable to you. Okay, so by now you might be wondering, what if the coefficient of x is negative? Like for example, if I ask you minus 7x greater than equal to 13, what would be the next step? Can we write it like this? Can we take minus 7 here? Yes or no? So yes guys, answer is the life is not always that easy guys, or not the same. I shouldn't use this easy word here because it is answer is no. So in case of equality we could have done it, okay, but in case of inequality we cannot cross multiply a negative number here. So this is not allowed. So if this is not allowed, what is the correct? Obviously we have to change the sign of this, but why? So the answer is, which moves us to the next rule, when C is negative, A is greater than B, and if you are multiplying it by C, where C is negative, or C is a negative real number guys, C, AC and BC, the sign is reversed guys. So if you multiply by an inequality, if you multiply by a negative number to an inequality, the sign of the inequality is reversed guys. This is the next rule. Okay. In a similar way it can be proved by using number line guys. So let's directly move on to some examples, like for example 4 greater than 3. Now if I multiply it by minus 2, this becomes minus 8, this becomes minus 6, right? 4 into minus 2 is minus 8, 3 into minus 2 is minus 6, and as you can see, minus 8 is lesser than minus 6. Okay, so which illustrates this uh, rule. This example illustrates it. So therefore, if suppose if it is minus 7x greater than 11, and you have to find x, in the next step you have to, in order to remove the coefficient, you have to multiply by what? Yes, minus 1 by 7. So minus 1 by 7 is multiplied both sides, and as soon as you multiply it, the two numbers, you have to change the sign of equality also. What I mean to say is, if it is greater than equal to, this will become less than equal to. Okay, the sign is reversed. So if suppose this is greater than equal to, this becomes less than equal to. Okay guys, so minus 7x into minus 1 by 7, this becomes x, this becomes minus 11 by 7, and similarly we can write it in interval form as x belongs to yes, minus infinity to minus 11 by 7, minus 11 by 7 included. Okay, so in order, so you cannot cross multiply in, so in other words, if you want to cross multiply a negative number from LHS to RHS or RHS to LHS, you should do what? Yes, like here, if you see, if you want to cross multiply minus 7 from here to here, you have to change the sign of the inequality. That way also you can remember, you can use this rule. Okay, so let's try this sum. Minus 11 by 3 x greater than equal to minus 2 by 5. So yes, you have to find x. So what's the answer guys? So yes, the hint would be the same. We have to cross multiply, or you can multiply it by, the hint would be either cross multiply plus 3 minus 11 here and change the sign, or else you can multiply, in order to make the coefficient of x 1, minus 3 by 11 both sides. So yes, that way if you solve minus 11 by 3 x, we have multiplied by minus 3 by 11 both sides, minus 2 by 5 minus 3 by 11. So we multiplied it by minus 3 by 11 both sides, guys. The sign is less than equal to, so this and this cancels out. X less than equal to, minus minus cancel, 3 2s are 6, 5 11 55. So x less than equal to 6 by 55, which you can write in interval form. Okay, so that way you can find x. Or else what you can do in another way, you can cross multiply 3 here. Since it is positive, it won't change the sign of the inequality in the first step. Now you can cross multiply minus 11 from LHS to RHS, but since you cross multiplied a negative number, the coefficient of x which was negative, after cross multiplying it the sign gets reversed and you will get the same answer. That way also you can understand or you can solve. Okay guys, so that way you can do. So now let's try some questions, guys. So try these questions, guys. So let's see the solution and the answers of first. So minus 5x multiplying both sides by minus 1 by 5, or simply cross multiplying the negative number which is minus 5 to the denominator of RHS, the sign of inequality is reversed. Okay, so this becomes x less than minus 13 by 10. Now let's do the second one. 1 minus 2x less than equal to 3 by 4. So 1 you can take on the right hand side, you can transpose on right hand side, so 1 becomes minus 1, minus 2x, taking LCM, 3 minus 4 by 4, minus 2x less than equal to minus 1 by 4. Now multiplying by minus half in order to make the coefficient of x as 1, both sides, minus 1 by 4 minus half, this will be reversed, so it will be greater than equal to, so this becomes x, cancels out. Okay, and this becomes minus minus plus, 1 by 4 into 2 8, or you can also say that by cross multiplying minus 2 from LHS to RHS, the sign of inequality is greater than equal to, which will again give this answer. So this is the answer, which you can write as x belongs to 1 by 8 to infinity in interval form. Okay, now let's take the third question. 5 minus x by 2 greater than equal to x by 3 minus 1. 5 minus x by 2 greater than equal to x by 3 minus 1. This is the third question. So first we can do it directly, but step by step we will do. I will first transpose 5 on the right hand side, so it becomes minus 5, minus 5, minus 1 will give minus 6. Now in the next step I will transpose x by 3 on LHS. It becomes minus x by 3, minus 6 as it is. Now taking minus common, minus x by 2 plus x by 3, and now we will take LCM, guys. So 2 into 3, this becomes 3x, this becomes 2x, greater than equal to minus 6. So this becomes 3x plus 2x minus 5x, 3 to the 6, minus 6. Now don't try to cancel minus sign. Now if you want to cancel minus sign, then you have to change sign, okay, or else you can cross multiply it like this. Cross multiplying minus 6 plus 6, which is in the denominator, to this side, it won't change the inequality, minus 5x. Now if you cross multiply minus 5, which is minus 36, by minus 5, the sign would be reversed. It becomes less than equal to, guys. Okay, so this becomes x less than equal to minus 36 by 5. Or if you want to cancel minus sign both sides, it means we are multiplying by minus 1. This becomes minus into minus 1, minus 6 into minus 1. The sign will be reversed. So cancelling minus both sides leads to the change in the sign. So it becomes 5x by 6 less than equal to 6. Now again cross multiplying 6 here on the right hand side and 5 in the denominator. This is plus 36 by 5. This gets cancelled. We will again get the same answer. So in you can do it okay, like this also, or like this also. So whatever the way, we have used the basic rules, and that way you can get the answer, okay, which is minus infinity to 36 by 5. Okay, guys. Uh, so guys, sometimes we may encounter questions like this: x minus half less than equal to 2x minus 7. There are two inequalities involved: 3x plus 1 less than equal to 18, comma. So if two inequalities are involved, and now we have to find x or the range of x, okay. So in that case, what we will do? So intuitively we can say that these two inequalities we have to solve, and we have to take something which is satisfying both. So these type of problems leads us to another concept, as you can predict, that it is about the common solutions. It is about common solution of two or more inequalities, okay, two or more inequalities, and we call this concept and concept, and of two inequalities, guys. It starts with two inequalities. You will start with two inequalities, and we can generalize it for more. So, and of two inequalities, this concept is what we have seen in sets, and is basically this inverted U, okay, this symbol and. So and of two inequalities is basically common solution of the two inequalities, Okay. Now how do we find the common solution of two inequalities? The concept is similar to what we did in sets and of two sets. So these two sets, here we will have the two sets as infinite sets. Okay. So what we have to do, we have to find intersection or common solution. We have to find intersection or solution which is common to both. So how do we find the intersection of the two inequalities? We will see that with some example, guys. So for example, x greater than equal to 2, x greater than equal to 3, comma. Instead of comma, this comma is equivalent to, guys, intersection only. Like instead of comma, if I write this symbol and, it is same. But generally they ask comma is given, which means we have to find the intersection. So what we will do, we will find x satisfying the first inequality, which is x greater than equal to 2. So we will plot 2 first, darken it since equality is there, and we will plot this, the second inequality. We will darken it here, the 3 would be included. Now what we will do, from each of the points we will drop perpendiculars. From point 2 we will drop perpendicular like this on the other number line of the other. From 3 also we will draw perpendicular on the number line of others. Okay. Now since we have to find common solution, now we can see here that from 2 to 3 solutions exist, but here it doesn't exist. So since we have to find common solution, so x belonging to 2 to 3, here also 2 to 3, it's not there, but here it is there. So 2 to 3 won't be in the intersection or the common solution. Now here if you can see, 3 is included here, 3 is included here. Okay. Now values greater than 3 are included here also, included here also. So this set of solution is common to both. Okay. So this blue line solution is common to both. So that is the answer. The answer to this is x greater than equal to 3. Okay, the intersection of x greater than equal to 2 and x greater than equal to 3 is x greater than equal to 3 only. So what we have to do, the first step is to, wherever the points that we are marking, from those points we drop perpendicular to the other side, to the other inequality. Okay. So that is a way of finding which part of the solutions are common and which part are not. So next example I will illustrate, you'll understand it more with other example. Like if I take x between -1 to 3, comma x 0 to 2, find x. Since comma is given, we have to find what? We have to find the intersection. So first we will plot the two inequalities. So we will plot this. Okay. So -1 and then 3. we will mark and we will join these two. Now here minus 1 is included, so we will place a dark circle here. Now the next inequality that we will plot would be x 0 to 2. So 0 lies somewhere between minus 1 to 3. So 0 I will mark here. Okay. So after marking, now 2 will lie prior to 3 somewhere here. So here I will mark 2 and I will join it 0 to 2. Okay. Now 2 and 0 both are excluded. Now we will draw perpendicular from the points. Like here minus 1 I will draw perpendicular to the other inequality, other number line. Here from 0 I will draw perpendicular. From 2 I will draw perpendicular. Okay. From 3 I will draw perpendicular. Now as you can see, now here also I will plot, write minus 1. Here I will write 0. Now as you can see here, from minus 1 to 0 there is no x, but here there is x. So their intersection, the common solution, there won't be any x here. Minus 1 to 0, there won't be any common solution. Now here this is 0. Here also I will mark 0 and 2. Now here as you can see, 0 is present. 0 is included in minus 1 to 3. But as you can see here, x0 is not present. 0 is not a part of solution in the second. So 0 we won't take. Okay guys. 0 won't be taken. Okay. Then so 0 is not there. Now moving further, 0 to 2 values. 0 to 2 values are present in both, as you can see. 0 to 2. 0 to 2 means both excluded. 0 and 2 are not included. 0 to 2, all the values between 0 and 2, they are included. So 0 I won't take, 2 I won't take, and 0 to 2 values are included. So they will be part of their intersection, guys. So now again moving further, from 2 to 3 there is no x satisfying. Now 2 to 3 there is some x, so their intersection, nothing we will get. So finally the answer is 0 to 2. We can also say that since 0 to 2 is completely a subset of minus 1 to 3, so the answer is x 0 to 2, or in interval form x belonging to 0 comma 2, both excluded. Let's take another example, guys. X 1 to 10, x 3 to 13. So 1 to 10 I will plot here. Here I will plot 1. Here I will plot 10. And 1 is included, so I will place a dark circle here. Now the second inequality, which is 3 to 13, 3 excluded, 13 included, I will plot. So 3 would be on the right side of 1, so 3 would somewhere lie here. Now 10 is here, so 13 would be on the right side of 10, so 13 would be somewhere here. Now I will join these two guys. Okay. So 3 to 13 is this. Now since 13 is included here, so I will place a dark circle here. After doing this, guys, we will draw perpendiculars. Now from 1 I will draw perpendicular like this. 3 I will draw perpendicular. Okay. 10 I will draw perpendicular. 13 I will draw perpendicular. Okay. Now you see here there is a solution from 1 to 3, but there is no x satisfying 1 to 3 here. So in the final solution there won't be any solution between 1 and 3. here 1 is included, but 1 is not included here, so 1 is not included, 1 to 3 is also not included. Okay, so nothing I will write here, there is nothing here, no solution in their intersection, guys. We are finding the intersection or comma, right? We are finding x. So now here again 3 is included, but 3 is excluded here, so here 3 won't be there. Okay, now 3 moving further, values greater than 3, they are included in both, as you can see. Let's say 3.1, so 3.1 is here, here also. Any value greater than 3 is satisfying this part as well as this part till which point? Yes, till x equals to 10. What about 10? 10 is not included here, but 10 is included here. So as you can see, all the values between 3 to 10 we will take. Okay, 3 to 10 we will take, but 10, since it is not common to both, 3 is also not common to both, so it won't be included in the intersection. Now moving on from 10 to 13, 10 to 13 values are included here, but here there is no value from 10 to 13 in the first inequality, so there won't be any common values after 10. So the final solution would be 3 to 10. So x belongs to 3 to 10, open interval x belongs to 3 to 10, x. Okay, so that way we find intersection of inequality. Now let's do one more example, you can also try it. Okay, x less than 4 less than equal to minus 1 comma, find x. So now again the method is same. We will plot it on the number line, we will draw perpendicular, and we will find the common solution. If you are well versed with, if you have done some good practice, doing it mentally also won't be, won't be an issue. So plotting x less than 4 first, drawing number line, and this we will mark 4 here. Since x is less than 4, all the values lesser than 4 we will take, that is minus infinity to 4 we will take, guys. Now we will plot x less than equal to minus 1. So again 4 minus 1 lies on the left side of 4, so minus 1 will lie somewhere here, minus 1 to infinity, like this. Now sorry, minus infinity to minus 1, minus infinity to 4. Now from 1, if we draw perpendicular like this, and from 4 also if you draw perpendicular, as you can see here in their intersection, minus 1 to 4 there is no values, but here it is minus 1 to 4, here it is values, here there are no values, so no common values between minus 1 to 4. Minus 1 is not included, minus 1 is not there, sorry, minus 1 is there, there is a dark circle here, minus 1 is here also, minus 1 is here also, so minus 1 we will take, guys. Okay, now moving further on the left hand side, all the values lesser than minus 1, and here also all the values lesser than minus 1, they are included. So the finally the common solution would be minus infinity to minus 1, minus 1 included. So that is x belongs to minus infinity to minus 1, minus 1 included, guys. Okay, so hope these examples gave you an idea as to how to find the intersection of inequalities, because in so many questions, if a question involves different uh, methods, sometimes we have to find solution, the final solution we have to find by taking intersection of them. Okay, so this is what we call intersection of two inequalities. Okay, now let's take another example, guys. You can try this as well. X less than equal to 9 and x greater than 7. Find x. Okay, so now I will draw this mark 9 here, x less than 9, so all the values on the left of 9 we will take minus infinity to 9. Okay, and then we will plot this x greater than 7. So x greater than 7, so 7 will be lying on the left hand side of 9 since it is lesser than that. 7 I will mark here, and all the values greater than 7, so I will it has to be on the right hand side of 7. So it is like this, 7 to infinity minus infinity to 9. So again proceeding with the same concept, we will draw perpendicular from 7. I will draw perpendicular from 9. I will draw perpendicular. This is 9, this is 7. Now as you can see here, from all the values lesser than 7, here it is included, but lesser than 7 values, they are not included here. So it won't be a part of the final solution, that is the intersection. There won't be any values between minus infinity to 7. Okay, now what about 7? 7 is there, 7 is there, but here 7 is not there. So 7 won't be included. Slightly, if you take a bigger value greater than 7, 7.001, so 7.001 would be included here. As you can see here, values greater than 7, lesser than 9. Okay, so values greater than 7, lesser than 9, as you can see in both, they are having intersection, they are having common values from 7 to 9. So all the values from 7 to 9 we will take. Now as far as 9 is concerned, 9 is not included here, although 9 is included here, so it won't be a part of their intersection. So 9, it would be an open bracket, so 7 to 9 would be the answer. X belongs to 7 to 9. Okay guys, now we have seen a basic inequality, like if x is, let's say, minus 1 to 4. Okay, this is one of the basic inequality that we have seen. The meaning of this, as far as and is concerned, it is the and of, it is the intersection of two inequalities, x greater than equal to minus 1 and x less than 4. So these two inequalities, if you take and, you will always get this. You yourself can try and get this. This is a concept, we can generalize it like this. Okay, if x is from a to b, the meaning of this is x is greater than equal to a and x is lesser than b. Obviously a is lesser than b. Okay, now suppose if here it is equality, equality will be there here. Suppose here equality is not there, here it won't, there won't be in equality sign. So that way we can understand this. Okay, so guys, now as I said, we have seen and of two sets. Similar to that, there exist union of two sets. So union of two inequalities, where it is used and why we are doing this, because in some questions, like for example x minus 1 mod 3x minus 1 less than equal to 2, we have to, certain questions we need to solve by taking cases, like case 1 we have to take, case 2 we have to take, and so on, case 3 we have to take, and so on. So solving the cases, when we solve a question by taking cases, the final solution guys, it is the union of all the cases involved. The final solution is the union of all the cases involved. Here in this case, let's say if there are three cases, so this is one of the example. This is a question example I have taken from modulus, and you will see it later. You will study it when you will do modulus. So in certain questions, we have to take union of inequalities. Now, if you remember what was union of two inequalities, two sets, what was the union of two sets? Union of two sets is basically collection of set of all solutions of both inequality. It is collection of all solutions of both the inequalities, or if there are more than two inequalities, collection of all solutions of all the inequalities involved in the union. Okay, so inequality, union of two inequalities, union, we have seen intersection, union is denoted by u, the symbol u. Okay, so if we are doing, u is used as the union symbol, guys. This is used as a what, as a method of taking union of inequalities two or more, and this is used as a symbol, as a connector in representing inequality in interval form. That also, that we will see. Okay, this is used as a symbol also, not only as an operator. For example, sometimes the answer may look like this: minus infinity to minus 1 union 3 to infinity. So union is, this is used as a symbol or a connector between different solution of lying on the number line. Okay, so u is used both as a symbol and as an operator. How we use union, how we do union, that we will see now, guys. Okay, so let's take example x less than equal to 3, or we also represent u by or. Okay, u and or are used, they are the same. Okay, x less than equal to 3, x less than 7. So we will draw a number line. We will first plot this, we will mark 3, we will x less than equal to 3. Okay, and then all the values lesser than 3 we will take. 3 is included here. Now the second x less than 7 we will plot. 7 lies on the right side of 3, so somewhere it was here, so I will plot 7 here. Again x is less than 7, so all the values lesser than 7 we will take. So minus infinity to 3 in the first case, 3 was included. Minus infinity to 7, 7 is not included. Again the concept is same, we will draw perpendicular from the points, okay, where the inequality is starting. So 7 3, I drop perpendicular. Now as you can see here guys, we are doing union. Union means what? Take everything, whatever this inequality has, whatever this inequality has, whatever the common inequality solutions they have, everything we have to take. Like from 3 to 7, this has values, this doesn't have values, doesn't matter. 3 to 7 we will take, because we have to take collection of, we have to take all the solutions of both the inequalities, whether common, like here they are common from minus infinity to 3, from 3 to 7 they are not common. Okay, so whatever the common or not common solutions, everything we have to take. So it will go on like this. Answer would be minus infinity to minus infinity to 7 guys. Okay, x belongs to minus infinity to 7. Okay, so likewise we can do things. We can take some example, previous examples of and we can do them, we can take their union. Okay, like let's start with this. Now if we have to, let's say if we have to find or, okay, the question is like this guys. So in this example we have to find or x less than equal to 9 or x greater than equal to 7. Okay guys, this again, this also I will rub. So what we will do, as you can see here, after plotting x less than equal to 9, okay, 7 to 9 is the common solution, minus infinity to 7 is uncommon solution. Whatever it is, whether it is common, whether it is this is uncommon solution from minus infinity to 7, we will take, because it is union, it is not intersection. Okay, this is union guys. And from 7 to 9 it is common, that also we will take. Okay, so 7 to 9, 7 is a part of this, it's not a part of this, so 7 also is there. So minus infinity to 9 we will take. Now since 9 is not a part of, since 9 is a part of this, that we will take. And now from 9 to infinity also we will take, so it will be the entire number line guys. What I mean to say is x belongs to minus infinity to plus infinity, that would be the solution. Equivalently, x belongs to R can also be written guys. Set of all real numbers, or if you write minus infinity to plus infinity, that is also correct, both are same guys. Okay, now previous example, now let's do it on a fresh board, because so many things are written, it may not bring that clarity. So we will do another example on a fresh board guys. Hope you understood that example. Now I will do it again, we will write it again, no problem. X minus 2 to 3 to 7, let's say, union x 5 to 10. Find the union of these two. So guys, we will draw minus 2 to 7. We will plot minus 2 and 7 here, let's say. Now the second inequality, in the first inequality 7 is included, so 7 we will place a dark circle here. Now in the second inequality 5 is on the right side of minus 2, it will lie somewhere here. So 5 I will plot here, and 10 would be on the right side of 7. 10 would be somewhere here, so it would be here like this, 5 to 10. Okay, we are finding what? We are finding the union. So again we will draw perpendicular from these points where the inequality is starting or ending. So minus 2, we will draw perpendicular. So as you can see here, from minus 2 to 5, minus 2 is not here, it is not here, so it won't be a part of their union. Although from minus 2 to 5, minus 2 to 5, there is no x here satisfying this, but minus 2 to 5, definitely the first inequality has x. So we will take, since we are taking union, we will take all the points from minus 2 to 5. Okay. Now moving on, 5 is included here. Although 5 is not included here, so 5 would be there. Values greater than 5 are now common to both. Okay. So these values greater than 5, here also greater than 5 values would be common to both. So I will stretch this solution further and further till 7. Now 7 is included here, it is included here also, so 7 is also included in the solution. Now moving ahead, after 7 to 10, x is satisfying this, but here there is no x, 7 to 10. So 7 to 10 also we will take, because we are taking the collection of both the solutions. So 7, so minus 2 to 10, finally we will take. So 5 and 7 will also be a part of it. So finally minus 2 won't be there, 10 won't be there. So the answer is x belongs to minus 2 to 10. Okay, that is the union. Hope you understood it. Let's take another example, guys. The union of two. Okay, let's take another example, guys. Now guys, if suppose x is less than 5 or x is greater than equal to 19 by 2, we have to find the union of these two. Again we will plot this 5, x lesser than 5, so we will take all the solutions on the left of 5, minus infinity to 5 it is. Now 19 by 2 is equal to 9.5. So 9.5 is on the right side of 5. So it is somewhere here. Let's say 19 by 2. Now x is greater than equal to 19 by 2. So all the values greater than equal to 19 by 2 we will take. So 19 by 2 to infinity it will be. 19 by 2 is included. Now if we have to take union, so this is what I was saying in the beginning. This is the illustration of using union as a symbol. As you can see here, minus infinity to 5 is here, but there is no x here, since we are taking solution which is satisfying both or any one. Okay, that is the union. So we will take minus infinity to 5 in our solution set of the union. Now 19 by 2 to infinity is there here, but here there is no value. So we will take 19 by 2 to infinity here. If we did by the same, either you draw it or you can do it directly also by dropping perpendicular. So 19 by 2 to infinity. Okay, so this is the union of the two inequality. So x belongs to, now the question arises, how do we write this? Because so far what we did, there was only one portion, one continuous portion of inequality solution on the number line we used to have. Now we have two portions of solutions scattered on the number line. One is this, and 19 by 2 to infinity is also there in our solution set, which is also there. So since there are, if there are more than one solution set on the number line, we write all of them and we connect them by this symbol u. So this is what I mean to, what I meant in the beginning, that u is used as a connector, as a symbol to connect the different solutions on the number line. So this is a use, this symbol u is used as a connector, and u as a concept also we have seen, which is the union of two solution, two inequalities, means take all the solution which is common to both, or which are not common also we have to take, we have to take all the solutions. That is what we mean by union. So and u as a connector also we have used this. Let's take another example about the usage of the connector u, like this. If I write one of the solution set on the number line like this, guys, minus infinity to minus 4, 0 to 3, 0 included, and 10 comma 10 to infinity. How do you write it in interval form? Write the solution in interval forms. How you will write? Okay, so again, you might have correctly guessed it. We will start from the left hand side. There are three set of solutions which are there, which are present on the number line, which are scattered on the number line. One is this, another is this, another is this. So we will write all the three and connect them with the connector, yes, u. So minus infinity to minus 4, union 0 to 3, 0 is included because 0 is dark circle here. So we will place a square bracket here, union 10 which is not included, so open bracket or round bracket, 10 to infinity. So there are two connectors we use here, one and another. Okay, so that's the use of the connector. Another example of use of u, let's take, again we have to find, we have to write in the form of 4 by 3 to 21 by 2, 13, 100, 400. Now we have to represent it in interval form. Okay, we have to write this in interval form. So how do we do this, guys? Now as you can see here in this is a unique example in which so far we have seen a continuous, set, an infinite set of inequalities from point A to point B, or from A to infinity, or from minus infinity to B. But here, as you can see here, we have taken, this question is having, we have to include these discrete points in the solution set. So how can we do that? So x belongs to, we can write it like this, guys. 4 by 3 is included, to 21 by 2 which is excluded, so round bracket. Now please see this union. Now discrete points, we have seen in set theory, they are written inside set of curly braces separated by comma, 1300, 400. That way we can write, guys. Okay, so that's a way of writing solution set in interval form. And let's take one more example. 4 to 13, this is 10. Now this 10 means what? As you can see here, the solution set is write in interval form. Again the question is same, write it down in the interval form. So what we will do, either we can write, we have two options of writing this, guys. First we can write it like this: 4 to 10. As you can see, 10 is not included here. This means 10 is, there is a break at 10. So we will take a break at 10. We will use a round bracket. Then again we will start from 10, starting with a round bracket till 13. Again round bracket, open interval. Since 13 not included, now we will connect it by u. This is one of the way of writing it. Or else we can write it like this: x belongs to 4 to 13. But since 10 is not there, this 10 alone would be written inside the pair of curly braces, and now we will write this sign, minus sign. Yes, so minus sign can also be written, guys. Okay, so using minus also we can write it down, guys. Using minus, the way of writing it in terms of minus, that we can do the use of minus in representing solution in interval form can be uh, done. Let's take another example illustrating the same. Like we did a previous example, similar to that, I will write minus infinity to 4, and this is, let's say, 11 to infinity. Write the solution. Okay, so what we did in the previous examples, from there you will write it like this: minus infinity to 4, and then 11 to infinity you will write, and connect them with this connector u. This is what we did in the previous example. So there is one more way of writing it in the form of interval using minus. What we will do, we will write minus infinity to plus infinity. We will take full. So minus infinity to plus infinity we have taken, but we need to exclude the solutions from 4 to 11 which are not there, which are not a part of the solution. So here we will separate, we will subtract, we will use this minus sign in representing the solution 4 comma 11. Now my question to you guys is, here 4 curly bracket will come, sorry, square bracket will come or round bracket will come? So 4 should not be, must not be a solution. So we are subtracting 4. So if you take square bracket, 4 would be excluded from this, which is correct. So we will use square bracket. This means 4 will have to subtract. So that is correct, because 4 is not a part of the solution. As you can see here, 4 is in the open bracket. And what about 11? Since 11 is a part of a solution, we cannot use square, so we will use open. So till 11, all the values from 4 till 11, but not 11, needs to be subtracted. So it means 11 is there in the solution, minus infinity to infinity, minus 4 to infinity, because 11 we put what, we put an open bracket. So always remember that these kind of inequalities, if here it is open, by while doing minus we have to put close. If here it is close, we have to put open here. Okay, so that sums up our discussion on union intersection. One example about intersection I wanted to give, guys, like one set also comes like similar to the previous problem. Now I will give intersection of these two. Union would be definitely this only. Okay, this or this, whatever the way you want to write. Now my question here in this example is the intersection of these two. Now as you can see here, if you draw perpendiculars 4, 11, there won't be any common solution. There is common solution, there is uh, solution here, but there isn't here. Nothing here as well as here. Here there is nothing, here there is. So intersection we won't get anything. So we won't get anything means what? This is the answer. There is no solution to this. No solution. We write it using this symbol x belongs to phi. Okay. Phi is a null set. Phi is null set. Okay. So we use this symbol. No solution is equivalent of writing x belongs to phi. Okay. Okay guys. Let's take an example guys. 3 times whole bracket x minus 5 by 2 less than equal to 2 times whole bracket x by 3 minus 1 comma 5 times x plus 16 less than equal to x minus 1. Now so far we have seen that we solve single inequality, but this is two inequalities separated by comma, and we know comma means what? Yes, intersection. Intersection means if this is inequality 1 and if this is inequality 2, whatever the answer that we get after solving inequality 1, let's say it is answer 1, answer 2 after solving inequality 2, we can take the intersection of these two to get the final answer. So that way we can solve it. So let's see the solution now guys. Solving inequality number 1. So directly 3 gets multiplied inside, so 3x minus 5 into 3 by 2 less than equal to 2 gets multiplied inside, so 2x by 3 minus 2, so 3x minus 3 5s are 15 by 2 less than equal to 2x by 3 minus 2. Now I will take this minus 5 by 2 on the right hand side, so 3x 3 3x less than equal to 2x by 3 minus 5 by 2 will become plus 15 by 2, sorry, minus 15 by 2 will become plus 15 by 2 minus 2. Now I will take this on this side LHS, so 2x by 3 becomes minus 2x by 3. Taking LCM, 15 minus 2 into 2 by 4, 2. Okay. Now here also taking LCM, 3x into 3 minus 2x upon 3 less than equal to 15 minus 4, which is 9 by 2. Here also, since this is 3 3s are 9, x minus 2x, so this is 7x by 3 less than equal to 9 by 2. Now we will cross multiply 3 since it is positive on the right hand side. So this 3 goes here, so it gets multiplied by 2. 7x less than equal to 27 by 2. Now 7 will go down. It will again cross multiplied from 7x. This becomes 7, 27 by 2 into 7, which is x less than equal to 27 by 14. Okay guys, this is answer 1 as I said. Now we will solve inequality 2, which was this. This was inequality 2 guys. So this we will solve. Okay, 5 times x plus 16 less than equal to x minus 1. So inequality 2 was 5 times x plus 16 is less than equal to x minus 1. So 5 gets multiplied inside, so it becomes 5x into 5 into 16 less than equal to x minus 1. Now x will go this side, it becomes minus x, 16 into 5, it is 90 less than equal to minus 1. Now this becomes 4x, 90 will shift to RHS, it becomes minus 90. X is less than equal to minus 91 by 4. Okay, so this is inequality to 2 answer 2. Inequality 2. Now the final answer is the intersection, because the question involved comma, the intersection of these two. So I1, answer of I1, I will directly plot. It is less than equal to 27 by 14, which is a positive quantity, 27 by 14. And I2, as you can see, it is less than minus 91 by 41 by 4. Okay, so we will drop perpendicular. Okay, and we will take intersection of these two. So from minus 91 by 4 to this point, which is 27 by 14, we have nothing in common, so it won't be the answer. But from minus 91 by 4, which is included here, 91 by 4 is also included here also. So the intersection of these two would be what guys? So the intersection would be what guys? The intersection would be minus infinity to, yes, intersection would be minus infinity to minus 19, 1 by 4. X belongs to minus infinity to minus 91 by 4 guys. That is the final answer. Okay, let's take another example. Let's take a multi-correct question. If x is minus pi to 3, then x can be, this is a multi-correct question. a minus 4 minus 3 3 0. So how do we will solve this, guys? So the hint is just plot this on number line, or mentally also you can try. You need to understand that pi is equal to 3.14. Now you can try, just substitute the options given in the question, because in multi-correct questions we need to check the options to get the correct options. So 3.14 is pi, so minus 3.14. So let's see the solution now, guys. Minus 3.14 x less than equal to 3. So clearly minus 4 is something which is minus 3.14 to 3. If the solution is this, where 3 is included, guys. So minus 4 is outside on the left of minus 3.14, which is pi, which is minus pi. So this won't be a solution. Clearly minus 3 is somewhere here, and 3 is also satisfying. 0 is also here. So answer is BCD. Okay. Let's take another example, guys. Number of negative integers satisfying x minus 17 by 3 to half. Now the hint is what? Hint is the same, guys. We will find the approximate value of minus 17 by 3, and till 0, although it is still half, but till 0 lesser than 0 we will count number of negative integers. That's the hint. Okay. So the solution I will write now. So marking it on the number line. Plus half is here. Minus 17 by 3 is minus 3 5s minus 5 2 by 3 in mixed fraction, or it can be right minus 5.67. 2 by 3 is 0.67. So obviously the first integer on the right side of minus 5.67 is minus 5, just slightly greater than this. Okay, although this is included, but they are asking for negative integers. So minus 5, then minus 4. So minus 3, minus 2, minus 1. Okay, although 0 is also there, but minus 5 to minus 1, there are 5 integers. So answer is 5, guys. Okay. Let's take another example. X less than 1, x less than 2, comma x less than 3, comma x less than 2025. What is the x which is satisfying all? So guys, The hint would be, it would be like thinking that if you take a value which is lesser than 1, all those values would definitely will satisfy this and this and so on, because x less than 1 is a subset of this. Each inequality that is on the right is a superset of the previous inequality. X less than 3 contains x less than 2, guys. X less than 2 contains x less than 1. That way, if you think, then you will directly say the answer is x less than 1. Okay. Or else, if you think like this, if you try to do it by number line method, x less than 1, and take intersection of all, then x less than 2, x less than 3, and so on. So if you take intersection, as you can see, these would be the portions 2025 which would be common to all. So this is the second way, by using the conventional way of solving it, marking it on the number line to bring more clarity. So again the answer is x less than 1. So both the ways you can do. So first way, by thinking that 1 is the superset of the previous one. Any inequality is the superset of the previous inequality given. That way, or the traditional way of marking on the number line and then taking the intersection of all, you will get the answer as x less than 1. Okay guys.